Welcome to another lesson from the series of Physics 9702. In this lesson, we'd brush up on our understanding of all 11 chapters from AS Physics, but we'd be doing so by solving the MCQs from most recent P1. And we'd be solving these MCQs backward so that we get to solve the most recently studied topic first. So, starting with the 40th MCQ from nuclear physics, it says a nucleus of uranium with a charge number 92 and mass number 238 decays in stages by emitting alpha particles and beta particles, beta negative, eventually forming a nucleus of lead with charge number 82 and mass number 206. How many alpha particles and how many beta particles are emitted during the decay chain, where the parent atom, that is uranium, converted into a daughter atom, that is lead? So we have solved such questions in our earlier videos as well, in which we agreed that in such cases we'd have to make two equations and we'd solve them simultaneously to find the number of whichever particle they are asking us to emit with it, right? So let's first draft an equation. We had uranium 92, 238, and the daughter atom we had was lead 82, 206, and then a certain number of alpha particles with charge number 2 and mass number 4, and a certain number of beta negative particles were emitted, right? So this right here is our equation. And by this time we know that for a nuclear equation, the charges have to be conserved, dono sides of equation per, and the masses also need to be conserved. That is the only possibility that the nuclear equation is correct, right? So what we are going to do right here is we are going to make an equation with the charge number, which should be balanced on either side, and then we are going to make an equation with the mass number, which of course are going to be balanced on both the sides. So let's write for mass number, because we have a 0 here and we know that in this equation there is going to be no m. So we'd get only one unknown, that is n, and it is going to be easier for finding the value of n, which we would then pitch in to find the value of m in the other equation. All right, so let's do this. We have 238 at this side. The other should also sum up to 238. We have 206 plus n times 4, then plus m times 0, which of course would give us 0, and we'd get 238 equals 206 plus 4n. So we get 238 minus 206 divided by 4. This would give us the value of n. Let me first bring my calculator. Salinji, I hope I was not judged for bringing calculator for these numeric values. Anyways, 238 minus 206, this gives us 32, and 32 over 4 is 8. And this is the value of n, and we had assigned two alpha particle के numbers. तो इसका मतलब है alpha particles emitted in this transition, this nuclear decay was 8. But we can see that option A and B both have 8 as alpha particles. We'd still have to work around to find out which one of these two options is the correct option. But one thing for sure, C and D are out of the race, right? Now let's do, for the charge conservation, we have 92 at left, and at right we have 82 plus 2n plus minus 1m. So we'd write 92. Let's take these to the other side and leave our unknown as the subject of our equation at the other side. 82 goes there, it becomes minus 82. We have minus 2n, and n we have already known as now 8. And this is minus m. And 92 minus 82, this gives us 10. Then we have 2 into 8, that is 16. This gives us minus 6, which minus of course on both sides gets cancelled, and we get m is equal to 6. So the correct answer should have been option A. Then Okay, so we have a question. A nucleus of magnesium 23 decays to form a nucleus of sodium 23, emitting a beta positive particle and alpha and a particle X. What is particle? Now, we have already studied that beta particle is never emitted alone, and that was to um, keep the energy conserved because beta has a continuous range of energy. So we agreed कि जब भी beta particle emit होगा, it would always be accompanied by another particle depending on the nature of emitted beta particle. If it is beta positive, the other particle always is going to be एन इलेक्ट्रॉन न्यूट्रिनो जिसको हम सिर्फ न्यूट्रिनो भी कहते हैं एंड हैड इट बिन अ बीटा नेगेटिव पार्टिकल जो इस केस में इमिट हो रहा होता तो फिर उसके साथ जो हमारे पास एक और पार्टिकल इमिट होता इट वुड हैव बिन इलेक्ट्रॉन एंटी न्यूट्रिनो जिसको डायरेक्टली हम सिर्फ एंटी न्यूट्रिनो भी कह देते हैं सो फॉर बीटा पॉजिटिव it should be neutrino. Then it says an up quark in a hadron changes to a down quark. The elementary charge is E. What is the magnitude of charge of change in the charge of hadron? Now, they are saying that we had an up quark. For that, we should have the charges of quarks on our fingertips. Up quark had a charge of 2 by 3 E, where E is the elementary charge. That is a charge on electron or positron, which is 1.6 exponent minus 19, by the way. And they said this up quark converted into a down quark, and the charge for a down quark is this one, right? And आपसे कह रहे हैं कि इस कन्वर्जन में whatever is the change in the charge वो आप find out करें. So all you have to do is you have to take a difference of these two values minus 1 by 3e. This eventually gives us plus, and e तो वैसे भी common है. 2 plus 1 gives us 3 over the common LCM is 3. These gets cancelled and we get to have an e. So the option C is the correct option in this case. Then it says the principle of conservation, of which two quantities are associated with Kirchhoff's first and second law are. We already know that Kirchhoff's first law is the conservation of charges, जिसको हम current law भी कहते हैं, which says current entering a junction should always equal the current leaving that junction, right? So first law is the conservation of charge. That means option A and B इन दोनों में से कोई would be the correct option. And then we know that Kirchhoff's second law, which is the voltage law, which says that the sum of EMFs should always equal the sum of PDs in a closed loop, right? So the second is for voltage and the first one is for charge. The first is the this right here, then is the correct option. Then it says that a potentiometer circuit is used to determine the electromotive force of a cell. The circuit includes a second cell of known EMF, known is E naught, and which we have to find is EX, and negligible internal resistance and a uniform resistance wire having linked PQ. Now EX is less than E naught, which of course is the case जो हमने potentiometer में पढ़ा था. The unknown potential must always be less than the source potential, which is E naught, right? So EX has to be less than E naught. The movable connection J, which we called the jockey at that time while we were discussing this question, it can be positioned anywhere along the length of the resistance wire. Now, which circuit is suitable for determining the unknown EMF, that is EX? Now, while we were studying potentiometer, if you could recall, we have seen that जो भी wire की length है, it should be connected to the like terminals of the battery, right? So it should be connected to both positives, which let me minimize it so that we can see all the pictures in one go at least. right? So the end either has to be connected with both the positives, यानी unknown और known दोनों के positives से, or with both the negatives. This understanding of our potentiometer cancels this option because the end is connected to positive of the source and negative of the unknown. And it also rules out, okay, it does not rule out any other possibility on the basis of this. Now अब इस जो हमारी ये वाली understanding है that it should be connected with the same poles, उसके basis पे see positive positive this might be an option, negative negative this might be an option, negative negative this might be an option. Now we'll have to go to the other understanding from this topic, which was K. Remember, in this type of question, we had to find the null point, right? The point where galvanometer gives us zero deflection. And while we were studying that circuit, we had seen that the unknown potential ka jo cell hai, this is the one that is connected with the galvanometer, right? And the symbol right here shows us galvanometer, right? Which in turn is connected to the jockey. So see, this option is then ruled out. Why? Because here the source cell is connected with the galvanometer and hence with the jockey. However, this is not the case originally. Originally, the unknown potential wala cell is connected to the galvanometer, which in turn is connected to the jockey. So this makes us conclude that in this case, option D is the correct option. Now we have another question from this same topic. It says the diagram shows a circuit with a battery of electromotive force 60 volts and a negligible internal resistance. That means in this case the EMF itself would be the terminal voltage, right? And a 20 kilo ohm resistor. This right here is a fixed resistor having value 20 kilo ohms, and a thermistor. Thermistor हमें पता है its resistance is dependent upon temperature. You increase the temperature and the resistance of thermistor drops. And it is also connected with a voltmeter, and just know that this voltmeter is connected in parallel to this fixed resistor. So whatever is the potential drop across this fixed resistor is going to be reflected in the reading of this voltmeter right here. Now they are saying that initially the resistance of thermistor is also 20K, and then the temperature of the thermistor decreases, and this causes its resistance to change by 50%. Yani at a certain temperature, the resistance of thermistor was 20K, and then we have decreased the temperature. As soon as we see that temperature was decreased, we should know that the resistance of thermistor must increase, right? And फिर ये आपको बता रहे हैं because see यहाँ पे they've kept it uncertain for you. For any one of you who does not know the relation between thermistor and resistor, this is the point where the things would get wrong, right? Because you wouldn't know that 50% increase हो रहा है या 50% decrease हो रहा है. But because all of us know that there is an inverse relationship, we know that जब ये कह रहे हैं कि resistance 50% change हुई है temperature decrease होने से, so we now know कि resistance यकीनन 50% increase हुई है temperature के decrease होने से. So 20K का 50% was 10K. तो इसका मतलब है टेम्परेचर डिक्रीज होने से 20K की रेजिस्टेंस चेंज होकर हैज नाउ बिकम 30K की रेजिस्टेंस. Okay, so it has now become 30K की रेजिस्टेंस. एंड ऑफ कोर्स टेम्परेचर चेंज होने से थर्मिस्टर की रेजिस्टेंस पे तो चेंज आया, बट फिक्स्ड रेजिस्टर की वैल्यू इज कॉल्ड फिक्स्ड फॉर अ सर्टेन रीजन. इट वुड नॉट चेंज विद द चेंज इन वोल्टेज, राइट? With the change in temperature. Now, after this change, what is the reading on the voltmeter? Because of course, voltmeter की reading सिर्फ component की resistance पे नहीं depend करती, जो कि of course इस fixed resistor की पहले भी constant थी, अभी भी थी. It also depends on the current passing through that component. And of course, current passing through this loop would depend on the equivalent resistance of this entire loop, which now has increased due to the decrease in temperature, right? And Kirchhoff law, the second law, it says that the EMF was 60, so the sum of potential drop across this fixed resistor and this thermistor would give us 60 as well, right? नाउ क्योंकि मुझे सर्किट का ईएमएफ पता है, दैट इज 60 टोटल सर्किट का है, राइट। सो मैं अगर सर्किट की इक्विवेलेंट रेजिस्टेंस यहाँ प्लेस कर दूं तो आई वुड बी एबल टू फाइंड द करंट पासिंग थ्रू दिस लूप, दैट इज द करंट पासिंग थ्रू दिस फिक्स resistor, which would be the same current which would pass through this thermistor as well. And once I know the current passing through fixed resistor, I know the resistance of fixed resistor, I can easily find the voltage drop across this fixed resistor. Clear? So equivalent resistance, yani resistance of this entire circuit, I'm seeing that both the resistors, like resistor and thermistor, they are connected in series. And series may we just add up the resistance. So 20k plus 30k gives us 50k ohm. And according to Ohm's law, V is equals to IR. So I should equal V over R. V is 60. R is 50. Do not forget to add this 10 raised to the power plus 3 in replacement of kilo, and we'd find the final answer in current. We have 60 over 50 exponent 3. This gives us 1.2 milliampere, right? And now we know that this current is passing through this as well as this. And don't you think कि ये divide होगी, right? Because loop में the same current passes through the entire loop. So अब मैं इस resistor की खास तौर पर बात कर रही हूँ, इससे पास होने वाला current is 1.2 exponent minus 3. इसकी अपनी resistance है 2 kilo, and इसके across potential drop आ जाना चाहिए using this formula. 1.2 exponent minus 3 multiplied by 20 exponent, let me write it here, plus 3. So 1.2 into 10, not 10, 1.2 into 20. This gives us 24, and then 10 raised to the power minus 3 plus 3. This gives us 10 raised to the power 0, which is 1. This is the final answer, right? So in this case, the option B is the correct answer. Then a cell of electromotive force E delivers a charge Q to an external circuit. Which statement is correct? The energy dissipated in the external circuit is EQ. How do we define EMF, or how we define energy? We have seen that voltage is energy dissipated per unit charge. So yes, this makes us conclude that. Okay, so let's just change the symbols on the basis of whatever they have provided us with. Here they said they are going to represent this voltage, this EMF with E, and energy over this charge. So we can say that the energy is the product of E and Q, where this E is not energy, it is EMF, right? So the energy dissipated in the external circuit is EQ. The energy dissipated within the cell is EQ. No, सारी energy within cell जो है वो dissipate नहीं होती. It is always the difference between the EMF and the terminal potential difference. The external resistance is EQ. That's also not the case. The total energy dissipated in the cell and the external circuit is this one. Because this equation में they said that electromotive force is EMF, and हमें पता है EMF external circuit के across तो drop होता है potential, but if the circuit has a considerable internal resistance, so remember we used to make ऐसी कोई डायग्राम, एंड वी वुड से दैट जो भी बैटरी का ईएमएफ है इसका सर्टेन पोर्शन विद इन द बैटरी टू काउंटर द इंटरनल रेजिस्टेंस ड्रॉप हो जाता है, एंड बाकी जो भी रिमेनिंग है इट गोज टू द एक्सटर्नल सर्किट. So this makes us conclude that option D here is the correct option, that the total energy dissipated in the cell and the external circuit is EQ. Now, a piece of wire X has a resistivity rho, length L, and cross-sectional area A. Wire X has a resistance R. Now, a second piece of wire Y is made up of a different material. That means it is going to have a different resistivity, right? It has the same resistance, but has twice the length of X. Now give us the possible value of its resistivity and its cross-sectional area. Now that we have known, बल्कि चलें पहले let's make the equation. We have to find resistivity and area, right? So equation is R is equals to rho L over A. This is for the wire X. Rho X, Lx, and Ax. And then we know that there is another wire, let's call it Y. Okay, they've already called it Y. They said that it has, let's make uski equation first. Ry should equal rho Y Ly over Ay. But right here they said that resistance uski wahi hai jo wire X ki hai. So we can write Rx here, but material अलग है, so we cannot still comment यहाँ पे. And then they said कि ये जो wire Y है इसकी length is twice the length of X, यानी Ly की जगह मैं 2 times Lx लिख सकती हूँ. Clear? They said that the length of Y is twice the length of X. So I can simply replace this Ly with 2 times Lx, and now I have to find this Ay as well. Given that the final answer should remain same, Lx और Lx तो हमारे पास बैलेंस हो गया. Now one thing we can do is, मुझे पता है we have Lx here, we have Lx here. मैं अपनी इक्वेशन को सिंप्लीफाई अगर करके कहूँ तो मैं कहूँगी यहाँ पे हमारे पास resistivity और जो एरिया का रेशियो था, now we have 2 times resistivity and then area, right? इन दोनों रेशो की वैल्यू मेरे पास सेम आनी चाहिए. Like the individual value might differ, but this ratio remains same so that the final value of resistance is same. That is what they have said, right? दोनों की resistance same है. One thing you can do is you put on 1, 2, 3, 4 चारों options की values यहाँ पर one by one, and then you see किस केस में हमारे पास numerator and denominator जो है वो equal value दे रहा है. Or the other thing you can do is you find an option in which 2 times resistivity gives us the area directly. Like you multiply this with 2, you get 1 times rho. Do you have 1 times area here? No. You multiply this with 2, you get 1 times rho. Do you have 1 time area here? Yes. Let's see baki ke 2 options as well. You multiply this with 2, you get 2 times resistivity. Do you have 2 times area here? No. You multiply this with 2, you get 4 times resistivity. Do you have 4 times area here? No, because that would then have given us the same ratio. This is also incorrect and this is also incorrect. So this makes us conclude that option B is correct. You would get the same answer अगर आप इनकी individual values यहाँ पर place करें. Like let me do this for option B now that we know that it is correct. 2 as it is. बाकी option B में इन्होंने कहा है density is half rho, and then area they said it is A, so A ki jagah we are going to continue with A. See, this 2 gets cancelled with 2, we get rho over A, and same was the case here, rho over A. So option B in this case is the correct option. Now in MCQ 32 it says current in a resistor of constant resistor is this one, the power dissipated by the resistor is this, and the current is then increased to this value. What would be the power dissipated? They've provided us values of current and resistance, and power dissipation के बारे में हमसे पूछ रहे हैं. Do we know of a formula that involves power, current and resistance? Power is VI, power is V square over R, power is I square into R, and that is the formula we should be looking for, right? Because it has current, it has resistance, and it has power. But the problem here is for the second case, we know we have to find power, and we know that the current is 12 milliamperes square from the formula as it is. We do not know the value of resistance. Once we know the value of resistance, we put it here, and we'd be able to find power. But they've mentioned that the resistance is constant, right? With the change of current, the resistance is not changing. So maybe we can find the value of resistance using the information provided in the first part, and we then use that same value of resistance to find the value after the current has increased, right? So initially they said that the current was 8, but the problem we have here is they did not provide us with anything other than current, right? So we cannot find the numerical value and then we can put it here to find the final answer. Besides, the option right here says that the final answer has to be in terms of previous power dissipation, right? So in this case, what we can do is abhi ki power dissipation, let's call it P dash, and the power dissipation when the current was 8, let's call it P, right? And let's find their ratio. Now, why did I think of finding its ratio? Is because I want this power in multiplication with the final answer. So it has to be in division with this power so that after simplification, it goes to the right side and comes in multiplication with the numerical value, right? So we now place the value of the power here, that is I square into r. अभी के केस में I square is 12 milli, r we don't know, over, and originally when the dissipation was P, उस time पे the current was 8, so 8 milli square from the formula, and then this r gets cancelled with this r, square square, and you get the final answer, this ratio times P. You divide these two, you get 2.25, and the 2.25 can be rounded off to 2.3. So this becomes 2.3 times the power dissipation when the current was 8. By the way, you can do the same thing because यहाँ पे they mentioned the resistance being constant, so I preferred going with the resistance. Otherwise, you could have tried it the other way as well, maybe in terms of voltage, but they didn't mention that the voltage would remain same, which we for a fact know that would not remain same, right? So in these cases, avoid going with the other way, and अगर कोई चीज उन्होंने constant बता दी है तो just stick with it. Then they say that a student connects two loudspeakers to a single signal generator. We have a signal generator, it is connected with two loudspeakers, so whatever is the source, it is being transmitted to these two, right? So that is a case of coherent sources, remember. Then as the student walks from P to Q, like starting from this point, the student is going away and towards Q, he notices that the loudness of the sound rises and falls repeatedly. What causes the loudness of sound to vary? The diffraction of sound source. Sound was not diffracted, no corner, no bending, no opening, nothing. Doppler shift of the sound wave. Doppler shift is either a continuous increase or a continuous decrease. And जब let's say source आपकी तरफ आ रही है, so there would be a continuous increase in the frequency. But then as soon as वो आपसे दूर चली जाए, then it starts continuous decrease. But फिर ये एक ही बार change हो रहा है, right? And then the दूसरा reason we cannot go with the Doppler's effect here is Doppler's effect is not concerned with the loudness of sound. Doppler's effect concerns with the frequency of sound, and frequency is related to the pitch, whereas loudness is related to amplitude, right? So option B cannot be a correct option here. Then we have interference of sound, and then we have reflection of sound. Reflection, of course, is not the case here. The correct answer is interference because we remember and started the Young's double slit experiment as well. And we said, let's say this is the point P. At a certain point, the waves from both the sources will be superimposing so that there is maybe no path difference or a path difference which is integer multiple of the wavelength. At this point, there would be constructive interference, loudness सुनाई देगी. And let's consider कि थोड़ा सा आगे this person has moved and now अब यहाँ पर जो हमारे पास दोनों sources की तरफ से waves आ रही होंगी, they would have a certain path difference. And let's say now this path difference is odd integer of wavelength, or we can say integer plus half of the wavelength. At this point, there is going to be a destructive interference, and loudness ke bajaye there would be, we can say decrease in loudness, or we can say इंटेंसिटी वाले टर्म्स में जब हम बात करते थे, सो वी विल से दैट देयर इज साइलेंस, राइट? एंड देन दिस वुड कंटिन्यू, थोड़ा आगे जाके द पाथ डिफरेंस वुड नाउ अगेन बी इंटीजर मल्टीपल, बट पहले के मुकाबले में थोड़ा ज्यादा, वुड गिव अ लाउडनेस, increased loudness, and then फिर यहीं पे along the same path at a certain distance again destructive interference would happen, leading to lower loudness of the sound. So the correct option here is the interference, and source तो वैसे भी coherent है ना, so interference की तो condition पूरी हो रही है. Then in question 30 it says two progressive sound waves, they move in opposite direction and then they superpose to form a stationary wave, which a statement describes an antinode of the stationary wave. Remember we said that let's say this is the starting point, this is the ending point, and let's say जो मेरे पास stationary wave बन रही है, it is this one, and then we said कि stationary wave travels along the medium, it reflects off the boundary, and 180 degree के phase difference के साथ it comes to the medium traveling in the opposite direction. And जब हम stationary wave पढ़ रहे थे तो हमने कहा था boundary पे हमेशा there is going to be minimum or zero displacement of the medium particle, and that is the position that we know as nodes. These nodes can also form in between wherever the displacement, wherever there is no displacement of particle, right? And इन्हीं nodes के जो opposite हमने चीज पढ़ी थी contrary, that was antinode, and we said that antinodes are at the positions where the displacement of medium particle is maximum. Now read these statements. How can we describe the antinode of a stationary wave? Position where the phase difference between the two waves is 0 degree, a position where the phase difference between the two waves is 180 degree. It has nothing to do with the phase, right? A position where the stationary wave has maximum amplitude, or a position where the stationary wave has minimum amplitude, maximum amplitude. Had they mentioned anti-nod के बजाय nod, तो फिर option D would have been correct. Now the equation n lambda is equals to d sine theta. It can be used with a diffraction grating to find the wavelength of visible light, and which quantity is not correct for use in this equation. This equation for diffraction grating an element with adjacent multiple number of, let's say, transparent regions or openings जिसमें से light pass होगी, and then सामने screen पे they would interfere, and then they would generate a pattern with a bright spot in between. Then we have first order maxima on both sides, second order maxima on both sides, third order maxima on both sides, and so on, right? And in this equation, this n is the order of maxima, lambda is the wavelength of whichever light was incident, and वो सामने स्क्रीन पर जो है वो आपको पैटर्न प्रोवाइड कर रही है, एंड और इन केस ऑफ वाइट लाइट जब वो मल्टीपल कलर्स में ब्रेक हो जाती है उसमें यू कैन कस्टमाइज दिस वेवलेंथ, राइट? एंड देन थीटा वुड बी द एंगल एट विच सामने स्क्रीन पर आपके पास वो order of maxima या minima आ रहा है, and then this D specifically in the case of grating is the separation between two adjacent gratings or slits, right? So this D is not the separation between this grating and the screen. It is the separation between these adjacent openings, right, or gratings. This makes us conclude that A is wrong. Lambda is still the wavelength of light and is still the order of intensity maxima, and theta is the diffraction angle. However, this D is not the distance between the grating and screen. Then a light wave passes through a single slit and a diffraction pattern forms. What happens to the frequency and the speed of wave when it is diffracted? Frequency does not change, speed does not change. Diffraction is when it bends. Option D is correct. Then a moving source emits sound of frequency 1200 hertz. That is, the frequency of source is 1200 hertz. A stationary observer hears a sound of frequency 960, that is the frequency observed, that is the apparent frequency or the shifted frequency. It is 960 hertz. The speed of sound is 340 hertz, and we have to find the velocity of source. Now, they did not tell us explicitly if the source of sound is moving away from the observer or it is moving towards the observer. However, having studied the Doppler's effect, we now know that agar observed frequency is less than the original frequency of source, that would only be possible if the source is moving away from the observer. Right? So this makes us conclude that the formula we have to place here would be observed frequency is less than the original frequency. So final answer of course कम कब आता है जब denominator में you have a greater value. This is the formula we'd go with. Let's just put in these values. We have to find the value of Vs. So we can write observed frequency 960. This gets multiplied here. And then on the right we have frequency of source as well as the frequency of sound wave, which is a velocity of sound wave, which is 340. Now we have sound ki velocity plus source ki velocity. Sound is 340, source we have to find. We just rewrite this equation and we'd get the final answer. And let me write the equation here for you. 1200 into 340. 960 would go to denominator. And then this is our subject of equation, right? 340 इसमें add हो रहा है तो दूसरी तरफ जाकर subtract हो जाएगा. So let's do this. Put in calculator 1200 into 340. Then you divide it with 960 and then you subtract 340 from it. Your final answer is 85 meters per second. But then again, 85 happens to be in option C, it happens to be in option D. But the key difference here is going to be the motion. 85 meters per second की speed से the source is going directly away from the observer or it is going towards the observer. Since the apparent frequency is less than the original frequency, this makes us conclude that the source must be going away from the observer, and hence the correct option for the MCQ 27 would be option C. Now the graph shows the variation of displacement with distance for two progressive waves, x and y, of the same type in the same medium. On y-axis we have displacement in centimeters and on x-axis we have distance. As soon as we say on x-axis we have distance, we know that एक wave के लिए जो along x-axis मेरे पास separation है, it would give us wavelength and not the time period. Now the intensity of wave x is I. Where is wave x? This one. The intensity of wave x is I and आपसे कह रहे हैं intensity of wave y find out करें. And see, आपको अपना final answer देना है wave x की intensity के terms में. So what we can do is wave y की intensity divided by wave x की intensity. So that this I then goes दूसरी side पे and multiplication में आपके पास आ जाए. The same concept we applied अभी पीछे power dissipation वाले formula में. Now the key concept here is we should know that intensity is related to the square of amplitude as well as the square of frequency. Since they did not give us any hint about the frequency, we will ignore the frequency. Okay, बल्कि यहाँ पे they've mentioned, बल्कि ये डायग्राम हमें बता रही है कि वेवलेंथ जो है वो दोनों वेव्स की सेम है, इसका मतलब है फ्रीक्वेंसी भी सेम है. सो फ्रीक्वेंसी की वजह से तो इंटेंसिटी पे कोई इफेक्ट यहाँ पर नहीं आएगा, राइट. So we'd just consider that intensity is related to the square of amplitude. For the intensity of y, we would write y के amplitude का square, and for the intensity of x जिसको इन्होंने I का नाम दिया है, we would write the square of the amplitude of wave x. Now what we can see here is wave x ka amplitude is this one, right? Which comes out to be 0.4. So denominator में I can write 0.4 का square, and wave y का amplitude is this one, 0.5 and 1 के right in between. That is, it is 0.75 and square. Do not forget to place this square here because सारी game ही उसकी है. Intensity is not related to amplitude but with the square of amplitude, right? And then यहाँ denominator में we have intensity of x, which is I. You take square of these two, you divide their answers, and then simply ये जो I है इसे उस फाइनल आंसर से मल्टीप्लिकेशन में प्लेस कर दें एंड यू सी फाइनल आंसर क्या आ रहा है. लेट्स डू दिस. 0.7 का स्क्वायर over 0.4 square, this gives us 3.5. Do we have an option that says, okay, we have an option, luckily, 3.5 times the intensity of x. So the correct answer is this one. Then, what is the phase difference between point P and Q on the progressive wave shown in the diagram? Point P, point Q, and let's see. This is one wave, right? And then from node to NT node, this is 90. Clear? So one wave के लिए the phase difference we say is 360. 360 plus 90 gives us 450. Or you could have done the same thing, यही 90 के packs में divide करके. Like you could have said this is 1 times 90, 2 times 90, 3 times 90, 4 times 90, and 5 times 90. So 5 times 90 would have given you 450. So option B is the correct option here. Then which rod describes a progressive longitudinal wave? Longitudinal and transverse, what was the difference? In longitudinal, the direction of oscillation is parallel to the direction of energy transfer or the direction of wave motion. This was for longitudinal. And for transverse, the direction of energy transfer is perpendicular to the direction of oscillation. Now it transfers energy in a direction parallel to the oscillation. That is true. It requires a medium to travel. Yes, because all the longitudinal waves, they are mechanical waves. They require a medium for their propagation. कुछ mechanical कुछ transverse waves भी हमारे पास mechanical हैं, like they also require a medium for propagation, like water wave, like a wave in a rope or a slinky spring. But there are also a few transverse waves which do not require a medium for propagation. For example, the entire electromagnetic spectrum. However, longitudinal sari ki sari, they requires a medium for their propagation. So true. They always travel at the same speed. No, it depends on the density of the medium as well. Then the graph shows how the extension of a spring varies with the force used to stretch it. जब आप stretch करने के लिए कोई force नहीं लगा रहे, उस time कोई extension नहीं है. Always keep in mind that in these graphs, extension is original length के बाद कितनी length जो है वो increase हुई है. Do not take it to be the final length, right? Now, what is the elastic potential energy of the spring when the extension is 4 centimeter? When the extension is 4 centimeter, the applied force is 30. पहले तो देख लेते हैं एनर्जी कैसे आती है. आप ऐसे याद रख सकते हैं कि एनर्जी इज फोर्स इनटू displacement, in this case force into extension. But then यहीं पे फिर आपको एक बात ये भी याद रखनी है कि we have agreed that in such cases the force keeps on changing. एंड देयरफॉर जब हम यहाँ पे एक्सटेंशन के लिए और इलास्टिक पोटेंशियल एनर्जी के लिए फार्मूला ड्राइव करते थे तो वी यूज टू प्लेस a half year, right? So now for the extension of 4 centimeters, 4 centimeters, the applied force was 30, but do not forget this kilo here. 30 exponent plus 3. And then क्योंकि मुझे जो final answer चाहिए energy का, it has to be in the unit of joules, which is the standard unit. For that I have to place force in its standard unit. That is Newton standard, right? I did not say base. Do not get confused. And we also have to place the displacement in its standard unit, which is meters. However, जो हमें value provide की गई है, it is in centimeters. So we are going to divide it with 100 and we'll get 0.04 meters. Now we'll put these two values in our formula. E equals half 30 exponent plus 3 into 0.04. Let's put these values in our calculator. Okay, so the final answer is 600 joules. So option C is correct here. Then a copper wire has a length 1.7 meters. It has a uniform diameter 0.64. Let's do it right here. Millimeters, because मुझे नजर आ गया था कि final answer में it says meters, not millimeters, right? So मैं पहले ही milli का factor लगा दूं यहाँ पर. The Young modulus of copper is 1.2 exponent 11 pascals, जिसको मैं न्यूटन पर मीटर स्क्वायर भी कह सकती हूँ. एंड स्प्रिंग कांस्टेंट मुझे अब फाइंड आउट करना है. यंग मॉडुलस मुझे पता है. यंग मॉडुलस इज स्ट्रेस, दैट इज force per unit area over strain, which is change in length per unit initial length. बट फिर मुझे यहीं से समझ में आ रहा था इन्होंने तो मुझे k फाइंड आउट करने को कहा है, राइट? सो व्हाट वी कैन डू इज k वाज द कांस्टेंट, राइट? आई कैन राइट f के बजाय kx and x was extension. Hooke's law, remember, f is equals to kx. तो मैंने f की जगह kx लिखा एंड इन दिस केस dx was extension. मैंने अपने फार्मूला में एक्सटेंशन को चेंज इन लेंथ का नाम दिया था, राइट? सो मैं kx के बजाय लिखूंगी k into change in length, right? Denominator में area, then यहाँ we have change in length over length. See, this change in length gets cancelled with this change in length. We are left with ka over L. Abhi bhi there are still simplifications to made. We have to find k. So rewrite the equation. Let's keep the k here and we send the L from denominator to numerator and the a to the denominator of the other side. This becomes the formula for k. अब मुझे young modulus भी पता है, मुझे length भी पता है. Area मुझे नहीं पता, but I have sufficient information to walk around the area, right? They are talking about the wire. Area of wire is pi r square. So I can just write pi r square. यहाँ पे they have provided us with diameter. We can simply divide the diameter with 2 and we'll know that the radius is 0.32 exponent minus 3 meters. So we just place 0.32 का square 10 raised to the power minus 3 का square, then pi 3.142. Length is given to be 1.7, young modulus is 1.2 exponent 11. Let's put these values. Okay, so the final answer is no way to be find out. What did we do wrong in this equation? Okay, we have a problem here. See, it was k and then denominator में area, जिसको हम ऐसे लिख सकते थे. It was k over a and then division था, place करते division and then we had 1 over L and then वही जो basic steps हम करते थे whenever we convert division into multiplication, the whatever the value given right next to the division wala sign, it gets flipped, right? So this became L, and मेरे पास formula होता K L over A, and दूसरी साइड पे जाने के बाद एरिया आ जाता ऊपर एंड लेंथ आ जाती नीचे. We made a mistake here. It would have been young modulus times area, which is pi r square, and then denominator में मेरे पास length आती. Now let's put the values in calculator अब and see if the final answer is in the given options. Here we go. The final answer we have is 2.27 10 raised to the power 4, or we can say it is 2.3 10 raised to the power 4 newtons per meter. This right here is the correct answer, option number A. Let's solve one last MCQ, that is 21, and then we'll cover maybe the first 20 in another video, because I for some reason know that you are going to leave this lesson just because you see so many minutes in there. Now 21 says a platform is supported by a spring. A box is placed onto the platform. The diagram shows the spring before and after the box is placed. Now, what is the term for the quantity marked as X? This X, of course, is compression. The length has reduced. The box placed would serve as a load, and its weight per unit area will give us a stress, and the change in length per unit original length will give us strain. So the answer for this change is compression. It is represented with X in this diagram. So let's keep it here, and I hope you have had some confidence and you'd be able to solve your past paper questions. See you in the next video. Till then, Allah Hafiz.